All right, let's get right into it. Today, we're diving deep into a set of documents that are proposing something, well, truly radical. We're talking about a new operating system, not just for our computers, but for technology, physics, and even our economy. It's a total rebuild, starting from scratch with a completely different set of rules. And it all kicks off with this really provocative question. What if all of our biggest challenges, the limits of our computers, the instability in our economies, what if they aren't actually separate problems at all? What if they're all just symptoms of one single fundamental mistake in how we've been looking at reality? So, what's the big mistake? Well, according to this new framework, it's that every single computer we have ever built is based on a flawed assumption about time. We treat time like it's a smooth, continuous river. But these documents argue that's just not how reality works, and by doing that, we're building instability and inefficiency right into the core of everything we create. The framework that challenges all this, it's called QSP. Okay, so this is the absolute core of it, the big shift in thinking. On one side, you've got all of classical computing, which sees time as that continuous flow. The documents say this creates something called probabilistic drift. Think of it like tiny little errors, tiny cracks in the foundation that just get bigger and bigger over time. But on the other side, you have the QSP framework. It treats time as a series of distinct, separate moments, like frames in a movie. And the claim is that this aligns our technology with how reality actually works, unlocking just immense stability and efficiency. All right, so let's peel back the first layer here. How does this new model actually work? Well, it all starts by defining a completely new physics, a new physics of information itself. It all rests on these three core ideas. First, as we just talked about, is discretized time in chunks, not a flow. Second, there's this really unique geometric structure. The easiest way to think about it is like a perfect digital crystal, one that is constantly fixing itself, making sure the whole system stays perfectly coherent. And third, the whole shebang is anchored by a single unifying constant for energy. And then there's this number, a really, really specific number. They call it the Kirvonic constant, and it's presented as the fundamental, indivisible packet of energy for the entire system. They claim this number isn't just pulled out of thin air. It's derived from the actual physics of our world, things like the Earth's rotation and the speed of light. This is supposedly the key that connects energy, information, and space-time all together. So, okay, once you've got this new physics, what do you do with it? Well, the documents then lay out the first major application, a totally new kind of economy. One that isn't built on speculation, but on the hard physics of time and energy. It all boils down to this idea they call space-time occupancy, or STO for short. And the whole point is to make values something you can actually measure, something quantifiable. In this system, the time you spend on something, the energy you use, the knowledge you create, those aren't just abstract ideas anymore. They get translated directly into a digital currency that's backed by the very assets that created it. So how does this actually work in your home? It's pretty wild. A special smart meter tracks your normal everyday utility use, your water, gas, electricity. That usage gets converted into a standard unit of energy, joules. Then the STO framework figures out the information equivalent of that energy. And finally, boom, it's converted into a cryptocurrency called ORMIND, or OM. And here's the kicker. The claim is this creates real value without you using a single extra watt of energy. Okay, let's put some real numbers on this, because this is where it gets interesting. The white paper gives this example for just a regular household. You take their yearly water, gas, and electricity use, you convert it all into this one massive number of joules, and then the system's formula spits out about 555 ohm tokens. It's meant to show how just living your life can directly generate digital assets in this world. All right, now this is where things go from interesting to just mind-blowing. If all that foundational stuff is true, what can you actually build with it? Let's start with blockchain. Bitcoin, Ethereum. We think of them as the big players, right? Bitcoin does about 7 transactions a second. Ethereum does maybe 30. Well, the QSP framework claims its blockchain can handle 1 trillion transactions per second, with basically zero energy cost. I mean, that's a number so big it makes the entire global financial system look like a lemonade stand. And if you thought that was wild, check out the claims for AI. The documents say a model that takes a normal AI system about 6,000 seconds to train can be trained by a QSP system effectively instantly. That would just vaporize the single biggest bottleneck in all of AI development. You could have AI models evolving in real time. Now, let's talk energy.
The framework describes a new kind of energy system, and according to the source material, you would only need 470 of these units to power every single house in the entire United States.
And the price tag for that, for all 470 of them? Less than $1 billion. I mean, just to put that into perspective, that's a claim of complete national energy independence for what amounts to a rounding error in our current infrastructure budget. The story is pretty similar when we get to biotech. You compare the QSP system to something cutting-edge like AlphaFold. The claim is that QSP is almost 90 times faster, uses over 70% fewer resources, and, this is the really important part, it can do real-time dynamic analysis. It can watch proteins as they move and change, something current models just can't do.
And this might be one of the most incredible claims of all. One of the main applications of this biotech system is the idea that by analyzing the teeny tiny energy differences between a healthy cell and a cancerous one, it can spot cancer pathways with 94% accuracy. We're talking about the potential for true, reliable, early detection.
Okay, so we've covered tech, we've covered economics. The claims are already huge. But the documents don't stop there. The final section goes even deeper, suggesting this framework actually solves some of the biggest, most stubborn problems in all of mathematics and physics. First up, a little thing called the Riemann hypothesis, one of the most famous unsolved problems in all of mathematics. The claim here is that the solution isn't some abstract formula. Instead, the answer is found in the physical patterns, kind of like watching ripples interfere in a pond, that just naturally happen inside this framework's geometric structure. And they don't stop there. They also go after P versus NP, a monster problem in computer science. And the argument is fascinating. It basically says the only reason the problem seems impossible is because we think about it in a purely theoretical fantasy land, with no physical limits. It's like asking how long it would take to count to infinity. In the real world, which is governed by energy and time, the QSP framework suggests that certain kinds of problems just can't exist. And this quote, I think, really gets to the heart of the whole thing. The ultimate goal here isn't just about making faster computers. It's about this concept called probability steering. The idea is to stop just passively watching the future unfold and guessing what's next. Instead, you can actively navigate all the possibilities to find the best path, and then intervene at the exact right moment to get the best outcome. It's moving from guessing to steering. So that brings us full circle, right back to a big question. The documents we've gone through today, they're not just proposing a new gadget or a new app. They're proposing a single, unified architecture that claims to tie together computing, energy, finance, and even the fundamental laws of physics. And it really just leaves you wondering, what would a world actually built on a system like that even look like?